Hello, every AI artists. Welcome to today's lecture. In the previous lecture, we created 6 views of our character. Today, our goal is to extract the character from these images and use them as training data set. Quick note, I adjusted the color of the character's pants to a consistent black leather pants. Now let's jump into extracting our character. Open up Affinity Photo or any other image edit tools. Select Crop tool. Adjust the width and height to 768 and 1344. Click Apply. Unlock the layer. Choose Move tool. Drag the image to position the character appropriately. You might notice some transparency on the left side. You can fix this by adding a white background below. Create a new layer. Use Fill tool to fill it white. And move the layer to the bottom. Lock the layer with the white background. Export the image. Name the files sequentially based on their order. After exporting the full body images, repeat the same process for the remaining views. I'll skip through this part. Once you've exported the 6 full body images, let's export partial images of the character. This will help enhance the accuracy of our clothing during training. Crop the upper body. Export the image. Capture the lower body. Export the image. The steps for the next image are similar. The side view of the character usually doesn't highlight the main features of the outfit, so we won't capture it separately. For the back view of the upper body, there's no need to extract it separately when the training sample size is small. Next, we need to capture the character's facial image. Adjust the width and height to 1024. Note that the captured image is better to include the collar part, not just the face. Capture the remaining images except the back view. I'll skip the repetitive process here. The processed images look like this. Next, I'll introduce the tools used to train the model. Open this web page. Copy this code snippet. Open the folder where Stable Diffusion is located. Click on the file address bar, type CMD, and press Enter. Paste the copied code and press Enter. Wait for the program to finish downloading. Once the download is complete, open this folder. Double-click the setup.bat file. The program will automatically start local deployment. If this is your first time deploying Koya, choose option 1. The program will automatically start local deployment. The deployment at this stage might be slow, so you can go make yourself a cup of coffee. I'll skip this part and show you the next setup steps. After waiting for quite some time, it's finally almost deployed. Now, we need to do some configurations. You can press up and down to select options. Choose this machine for the first option and press Enter. Here, Enter means confirmation. Choose No Distributed Training for the second option. Choose No for the next 3 options. Choose All here, lowercase, not uppercase. Here is a bad example that I hope will get your attention. If your graphics card model is NVIDIA 30 series or above, choose BF16. Otherwise, it's recommended to choose FP16. Choose 5 for the last option. Alright, this is our model training tool. But before we start training, we need to label the training set to tell AI what we want to train. By the way, next time you can double-click this file to launch Kohya. Click on Blip Caption. Select the folder where the training images are located. Set batch size to 8, use 10 beams, min length 29. Click Caption Images to let AI label our images. Here you might encounter a common error saying the size of tensor A must match the size of tensor B. You can solve it this way. Open the folder where Kohya is located, find and open the requirements text file. Press Ctrl and F keys, search for transformers. Change the version name to match mine here, then save the file. Type CMD in the address bar and press Enter. Input this command and press Enter. Then restart Kohya to resolve the error mentioned earlier. And you can start captioning. Now it is done. Let's see the results of blip captioning. Overall, it seems fine, but upon closer inspection, you can find issues. The decorations on the head are mistaken for horns, and our character isn't holding a sword. Similar problems are present in the captions of other images. This usually happens because our character is kind of unique, so we need to resolve this by manually annotating. First, let's see how to annotate the training set. In fact, doing this is somewhat similar to writing prompts. We need to describe the main subject, background, etc. But unlike writing prompts for generating images, we should try not to write details. The parts we don't describe will be considered by AI as parts to learn. Let's look at the structure of dataset annotation. It's similar to writing prompts, right? The difference lies here. If our training set has some unique perspectives, but we only want AI to learn the characters, not those perspectives, we can label these perspectives, telling AI not to learn them. Medium works the same way. For example, if the characters in the training set are 3D rendered, but you don't want AI to learn the 3D rendering effects, as it might introduce strange noise specific to 3D rendering in the generated images. So, you add a tag like 3D rendering. Let's talk about lighting. If there's a lot of special lighting conditions like backlighting in your training set, you should write tags like backlighting to avoid AI deeply associating this lighting condition with your characters. Otherwise, you might end up with characters always having this backlight effect in the generated images. Finally, for quality, if you lack confidence in the clarity of your training images, you can add negative tags like bad quality or low resolution. Tell AI not to learn the image quality. This way, AI will focus on learning the actual features of the characters, not just the visual effects. It will make your trained characters more versatile, compatible with various art styles, rather than just reproducing the effects from the training set. Here I created a refined version. You can compare it with blip caption. First, I described the main subject using simple language. Since the background is white and I don't want AI to learn the background color, I added white background. I added tags like 3D rendering and low quality to focus AI on learning the character's features, not just the visual effects. So how do we call our trained character in the prompt? We add a trigger word. Usually it's the character's name. After we understand the concept, we can back to Kohya. You can fill in our trigger words, which is the character's name. Postfix can be filled with the parts we don't want AI to learn. So let's fill in white background, 3D rendering, low quality, and low resolution. The next part is the same as when we first used blip caption, just configure it. Click Caption Images. The main purpose of this lecture is to help you understand how to handle the training set, the reasons for manual captioning in special cases, and important things to note. After the program is executed, it will display a prompt saying Captioning Done. Then I will make some manual adjustments to the captions. For example, this is the initial caption for the first image. I modified it to look like this. Then, copy the entire content as a template. Open the second file, replace the content directly, and remove front view. Open the third file, replace the content similarly, and replace front view with side view. Back view. For this one, pay attention to changing full body to upper body. Remove the description of the lower body and add cropped. Similarly, this should be lower body. Close up. I won't show the rest because you should already understand how to caption. You can download this file and take a look in the course resources folder. Alright, we've covered a lot in this lecture. I hope you now understand how to handle the training dataset. See you in the next lecture when we'll officially start training our character model. Until then,